For this video, we will be discussing October-November 2024, paper 1-2. So let's start with question number 1. We are given a diagram, and the diagram shows the curve with this equation. Then the general equation given here is y equals to a sine bx plus c for 0 until 2 pi, where a, b, c are positive constants. So please highlight the keyword positive for all the constant a, b, and c. They want us to state the values of a, b, and c. Alright, so before that, we need to know what is the original pattern or the basic function for the graph here. They have actually given us a very obvious hint where the basic function for this particular graph is sine graph. Okay, so to figure out what is the value for a, b, and c, basically what you can do is that usually we'll try to compare it with using the original formula for sine x. Right, so I will want to sketch an original sine x here. Original sine x for one cycle will start from 0 and 0, go up and then coming down again and then go back to the x-axis. Alright, then we need to know all the important points here. This one is 0, then cross the x-axis at pi, cross the x-axis another time at 2 pi. Okay, then for the maximum and minimum point, the highest point here is a 1, the lowest point here is -1. And at the highest point, it should be pi over 2 for the value of x. At the minimum point, okay, minimum y value, the x value should be 3 pi over 2. Alright, and then one more thing that that is worth for us to figure out is we need to know what is the amplitude or what is the distance. Alright, usually for me, I will just tell the student that there's a center line for the sine graph. This is what I call a center line. That means it separates the positive part of the graph. This is a positive part on top of the x-axis and also the negative graph. Okay, so this original line, okay, the center line, I call it a center line, it will be actually y equals to 0 for the original graph. Right, and then the distance from center line to the maximum point is 1 unit. Okay, so the bottom part also the same, it will be 1 unit here. This is something very basic about the sine graph. And usually it will be very helpful for us to figure out what happened or what is the transformation that carried out to a new graph. Okay, right, so let's have a look for a new graph here. So first of all, we need to figure out where is your center line. So my original center line is y equals to 0 with the unit on top and unit at the bottom is the same. The distance from center line to top and also the center line to the minimum point will be the same. Okay, so let's figure out the center line first. So if I figure out carefully, from the highest point to the lowest point, there are totally 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8, right? Therefore, the center line by right should be somewhere here. So this is what I call it as a center line. So at this particular graph here, you can see that the center line is equals to 3. How can I have the center line equals to 3? So you can see that we are trying to move the graph maybe 3 units upwards. Okay, because originally the center line is 0, and now the center line becomes the 3. Okay, the possible transformation that we have is we are moving up the graph for 3 units. So when you're having a translation for the graph up 3 units, it actually tells us that we are having a plus c. And the c here should be a unit of 3 because the plus c is outside the basic function where it means it is a translation in the vertical direction. Alright, so I'm translating my graph 3 units upwards. Therefore, the c is a 3. Okay, so after I figure out my center line already, and now I'm going to figure out what is the stretch in y direction. Okay, so the stretch in y direction, we can have a look by using the original unit here. From the center line to the maximum point is a 1 unit. So now I would like to figure out from center line to the maximum point that I have here is this length, the purple color one. So what is the unit here? You can see clearly that the highest point is 7. The center line is a 3, right? So 7 minus 3, you are having 4 units here. So let us double check. How about the center line to the minimum point? So this is the center line to the minimum point here. If you try to figure it out also, it is having the same unit as the top one, which is also the 4 units. Which means that your original graph is 1 unit and now it becomes 4 units. It also tells us that the graph has go through a stretch in y direction. So a stretch in y direction, and what is the stretch factor? 1 becomes 4. Therefore, the stretch factor will be a 4. When we are talking about the stretch factor, it is basically we multiply a number outside the basing function. So when I multiply a number outside the basing function means the a. Okay, I multiply a outside the sin x, so it is a stretch in the y direction, and the a value should be a 4. Okay, so this is how we decide. And after that, let's have a look for the sine bx. How can we decide the bx here? So the b is a value inside the basic function, where it means it is a stretch in x direction. For the stretching in the x direction, it will affect our length for the cycle. Okay, so you can see that from here to here, it is 2 pi with 1 cycle of graph. Okay, so let's have a look for our new graph here. We are also having 2 pi from here until here. Right, these are 2 pi. But if you have a look for 2 pi, how many cycles do I have for the sine graph here? So I highlight it here. This is the 1 cycle. When the graph go up, come down again, and then go back to the original x, this one we call as 1 cycle. And now in 2 pi, for the new graph here, and you can see that I'm having basically 2 cycles. Okay, so 2 cycle of sine graph in 2 pi. Originally is 1 cycle in 2 pi, and now it becomes 2 cycles in 2 pi. That means I'm having a stretch in x direction with a scale factor 2. Because I multiply this with 2, where you have to divide all your x value by half, or divide by 2. Okay, so that's why you are having double up the cycle. Alright, so this is how we decide the value. So as conclusion, you can decide slowly, okay, by comparing the new graph with the old one, with the original one, and the conclusion is a equals to 4, b equals to 2, and c will be equals to 3. Okay, yeah, so please make sure that you fully utilize the original graph and also the details in the original graph so that you can figure out the correct value from here. Right, so this is what we have for part A. Let's have a look for part B. Okay, for part B, they are saying that for these values of A, B, and C, determine the number of solutions in the interval of 0 until 2 pi for each of the following equations. When we are talking about the number of solutions for 2 equations, right, basically we are looking for the intersection point for the 2 graphs. So let's have a look for part 1. They are talking about a sine bx plus c equals to 7 minus x. When you want to solve this equation, right, basically we want to find out the intersection point between this particular graph and also the other equation, which is y equals to 7 minus x. So try to think carefully when they want us to get the intersection point or when they want us to get the solution. Basically, we have to solve them simultaneously. So we are doing it a bit backward. They give us the equation to be solved, but I try to separate, but I try to separate into 2 different equations here, and I'm looking for the number of intersection point, because the number of intersection point denotes the number of solution. Alright, so for the first graph, it is already given in our question. So a sine bx plus c is already given. What we're going to do is like we have to sketch the graph for 7 minus x. Right, so how to sketch a graph for 7 minus x? If you want, you can try to figure out any 2 points. So let's say I'm having, I let y equals to 0. Then my x is equals to 7. Okay, and if I let x equals to 0, then my y will be equals to 7. Then I try to plot this particular line in the graph and try to figure out how many intersection points do I have. So 0, 7, and 7, 0. Okay, so let's have a look here. I try to clean up all the drawing that I showed just now, so they can see everything clearer, right? Okay, so let's have a look for the graph here. This is original graph that I have, and I want to sketch the graph y equals to 7 minus x. So just now I already find out the intersection point, right? Sorry, I already found the x and y intercept, right? Which is 0, 7 and also 7, 0. Okay, so 7, 0 is, sorry, the 0, 7 is somewhere here. 7, 0, it will be somewhere, I think it is out, a bit out of our scale, right? Because in our scale here, we're having 2 pi. 2 pi, 2 multiplied with pi, it will be 6 point something. So the 7 is out of the range. Maybe what we can do is like we try to substitute another value, which is easier for us. Maybe we can substitute, what is the value that we can substitute? Yeah, maybe we will let, just now we let x equals to 0, right? Then we get a y. And now maybe we can let x equals to 3. Then what is the value for y? So y will be equals to 4. So I plot the graph 3, 4. So 3 means slightly lower, slightly smaller than the pi. So pi is 3.142. So slightly smaller for pi is maybe here, and then it will intersect at 4. Okay, so maybe I try to plot it like that, so you can have a try. And we try to connect these 2 points together by using a straight line. Okay, by using a ruler, so you can sketch it in your diagram. And let's have a look how many intersection point can I get from here. Okay, so let's count. I have the first intersection point, second, third, fourth, and also fifth. All right, and then because for this question, they mentioned that they are looking for the number of solutions between this range only, from 0 until 2 pi. Okay, so I try to sketch the diagram and try to figure out the intersection point. I'm having 5 intersection points for these two graphs. Therefore, the number of solutions of this question will be 5. Okay, then we do the same thing for part number 2, part B number 2. So they want us to find out the number of solutions for this graph equals to 2 pi x minus 1. And now we are looking for y equals to a sine bx plus c. This is already given, right? And I want to figure out the graph for y equals to 2 pi x minus 1. All right, so let's plot this graph and see what do we get. Okay, so I go back to the graph one more time. I try to copy out the particular equation that I want to sketch now. I want to sketch y equals to 2 pi and then x minus 1. Okay, and we try to figure out, yeah, what point can I, how to find out the intersection point so that I can draw. Oh, sorry, maybe I want to find the x and y intercept, not the intersection point first. Okay, so try to find the x or y intercept, or maybe any 2 points that lies on the line. Okay, so maybe what I try to do is like I will try to let x equals to 0. But if I let x equals to 0, I'll get negative value for y, which is already out of the range also. Not convenient for us to draw it. Maybe I try to let x equals to 1. If I let x equals to 1. Okay, so I'll let x equals to 1. So let x equals to 1. And the value of y that I get is basically a 0. Okay, so I need to find out where is x equals to 1. Pi is 3.142. Pi divided by 2 is around 1.5 over. Okay, and we are looking for x equals to 1. So maybe it should be somewhere here. Okay, so you try to figure out where is it and then you try to plot the point. So x equals to 1, y equals to 0. Then how about another point that you can try to figure out? So if you want, you can try to figure out something like maybe you let y equals to a number. Maybe if you let y equals to 3, what do I get? Yeah, I'll get a very weird value, right? Okay, so maybe I let x equals to 2. Or I let x equals to 3. So if I let x equals to 3, I'll be having y equals to 4 pi, which is also out of the range already. Okay, so I put x equals to 2 lah, better. X equals to 2, then y, what is the value for y? You substitute 2 inside, you're having 2 pi. Y equals to 2 pi. 2 pi means that it will be around 6 point something. 6 point something, but should be less than 7. Okay, so it should be 6 point something when x equals to 2. But where's the x equals to 2? So we try to figure out a little bit more. Okay, so I just simply draw, yeah. So for you, maybe you try to figure out where is the exact value for x equals to 2 if you want, so that your graph looks better, okay? All right, then after that, after I draw the graph, then I try to connect the 2 points together by using a ruler. So this is my line for y equals to 2 pi and then x minus 1. Then now we try to figure out how many intersection points do I have here. So you can see that there's only one intersection point within the 0 until 2 pi. Therefore, for this particular question here, the number of solutions that we have will be only 1, because you can see only one intersection point, right? So we can just directly tell them that we are having one solution for this question. Okay, yeah, so this is how we solve question number 1. Okay, so we are now at question number 2. The first term of an arithmetic progression, highlight the keyword arithmetic, is -20. So I know that the first term, usually we denote it by using the A, right? And the common difference is 5. For common difference, usually we denote it by using a D. Right? So now there are a few important keywords here. We have the arithmetic progression. We have the first term value. We also have the common difference value here. They want us to find the sum of the first 20 terms of the progression. So sum of the first 20 terms. Okay, so for any arithmetic progression, right, so how to find out the sum of the first n term? The general formula for it is n over 2, 2a plus n minus 1d. Of course, if you can't remember this particular formula, you can refer back to the MF19 that we have. I think this formula is provided in the formula booklet. Right. So now because I want to find the first 20 terms, so I'm going to get S20. So my n will be 20 here. Okay, so 20 divided by 2, 2a. So 2 multiplied with a, which is -20, given in the question. n minus 1 is 19. D is a 5. Okay, so this is a very straightforward question. So please substitute the value in correctly and also try to get the final answer here. It should be 550. Okay, all right, so let's proceed to part B for this question. For part B now, they are telling us that sum of the first 2k terms is 10 times the sum of the first k terms. I want to translate this particular sentence into a symbol here. Sum of the first 2k terms means S2k. Sum of the first k terms means SK. Alright, then it is 10 times of SK. So when I want to write out in this equation, it will become something like this. S2k equals to 10 times of SK. Okay, and now they want us to find out the value of k. So this question again, they are still talking about the arithmetic progression. Therefore, to find the sum of the first n terms, I still apply back the same formula here. Alright, okay, so let's have a look here. So S2k means that I'm having n over 2. My n now is 2k. So 2k over 2. 2 times a. A is still -20. Okay, n minus 1. N is 2k now, minus 1. Then d is a 5. Equals to 10 times of, okay, so sk. K is the n divided by 2. Okay, then 2a plus n minus 1. So now the n is a k. D is still a 5. Okay, so maybe I should put a flower bracket here. Okay, and try to simplify everything here. So maybe you can cancel off the k, the 2 and the 2. Then try to simplify everything inside. You'll be having k, and then -40 plus 10k minus 5. If you do it very carefully, then for this part you're having 5k, -40 as well, plus 5k minus 5. Okay, so try to figure out all the equation here. Eventually, right, you'll get the value of k in a few more steps. Okay, so I will get 15k if I group all the k to one side equals to 180. Therefore, the k should be equals to 12. Okay, so this is what we have for for question number 2. Alright, so now let us discuss question number 3. We are given an equation, and then we have 2 points here. The x, a and b lah. They give us with a and b, and then we have the x coordinate for a and b. The x coordinate for a is a 2. The x coordinate for b is 2 plus h. Okay, and then both of them lies on the curve. They want us to find and simplify an expression for the gradient of the chord AB in terms of h. Right, so let's have a look here. If let's say we are having this particular curve, I simply draw, and then I'm having the point A. So let's say my point A is here. Point B, let's say, is somewhere here. And they form a chord, right? A to B. They form a chord. Okay, sorry. My line is not nice. Okay, so A to B. And then the x coordinate for A is a 2. The x coordinate for B is 2 plus h. So 2 plus h should be more than 2, right? So it should be on the right side of A. Okay, and then now they want to find out the gradient of the chord AB. So how to find the gradient for this blue color line here? So you have to use the coordinate geometry that we learned earlier, right? To find the gradient, the general formula is y2 minus y1 divided by x2 minus x1. But before that, I need to know what is the y coordinate for both points here. Right? Okay, so at x equals to 2, if I want to know the y coordinate, my y coordinate is y equals to 2 and then 2 square minus 3. Y coordinate that I get here is a 5. And this is my point A, alright? So you know that A is basically 2 and 5. How about at x equals to 2 plus h? What will happen to the y coordinate? So you're having 2 and then substitute 2 plus h into the y equation. Then you can, if you want, you can expand it. Okay, but maybe for me, I just keep it in this way first. Right, then I know that my b is 2 plus h, and then it is 2, and then 2 plus h square minus 3. And now I want to find out the gradient. To find the gradient, I can take y2 minus y1. So it depends on you which one you want to take. I will be taking b minus a, right? So 2, then 2 plus h square minus 3 minus the a coordinate, which is a 5, right, for the y, divided by 2 plus h, x2 minus x1, which is a 2. Okay, then to simplify this particular equation, I think I need to expand it. So I'm having 4 plus 4h plus h square. Oh, sorry. No 4. Okay, so h square minus 8 divided by h. Further simplify it, you'll be having 8 plus 8h plus h square minus 8 divided by h. Okay, then again, continue to simplify further. You'll be having 8h plus h square divided by h. And therefore, you can see that there are some common h here, right, where you can simplify them. And eventually, you are having 8 plus h. So I did a careless mistake here, right, just now. For this part, I think I need to multiply the 2 inside the h square, and I get the 2 here. Okay, then this also I should get a 2. So when I simplify, I should be having 2h. So this is the gradient for the chord AB. Alright, so that means I want to know the gradient for this particular line, right? I need to know what's the exact coordinate for the B, not in terms of h. Right, if let's say the B is having x coordinate of 3, okay? If it is 3, that means my h is equals to 1. So to get the gradient, you straight away substitute h equals to 1 here. Then you can get the gradient very easily. Right. Okay, so let's have a look for part B. For part B, they're asking, explain how the gradient of the curve at point A can be deduced from the answer to part A and state the value of this gradient. Alright, so let's have a look. They are asking us, how can I get the gradient of the curve at point A by using the result that we have here? Okay, so if let's say they're talking about gradient of the curve at point A, that means it is the gradient of tangent at point A. Okay, so we can try to figure out, yeah, if let's say my B is not so far away from the A, let's say my B is here. Okay, so you can see that, oh, A to B, the gradient is a bit different. Then if I make the B even closer to the A, so the gradient might be a bit more closer, okay, it's different again. Then if let's say my B is very, 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 very close to A, eventually it will become the gradient of A, which is the gradient of tangent at point A. Okay, but maybe the situation is you have to make sure that the B is very, very, very close to A. How can I make sure that the B is very, 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 very close to A? That means when the H is very, 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 very small, which is almost 0. Okay, because if let's say H equals to 1, that means the B is having the X coordinate 3, which is quite far away from the A. If I want to make sure that the B is very close to A, then I will need to fix I will need to fix the H, which is very close to 0. If the H is very close to 0, then eventually I will get the gradient of the curve at the point A, because they are very, very small, which is very, very close. Okay, it seems like it is the gradient at the point A eventually. Alright, so I hope that you understand the explanation here. So to explain this one, what we can do is that we have to tell them when the H is very, very small or very, very small until going to be a 0, okay, the gradient of AB will become the gradient of the curve at point A. Okay, so because when B is very, the H is equals to 0, right, the B is very close to the A. It seems like they are very, very close, and then the gradient is almost the same like the gradient of the curve at the point A. So the important part is this one. You have to know that the H must be almost 0. Alright, and now they're asking what is the gradient. If let's say H is almost become 0, therefore when I want to get the gradient, I also assume that the H in the gradient is almost 0 as well, and eventually you will get the gradient equals to 8. Okay, so if you want to double confirm and see whether the answer is correct or not, you can actually double check by using the dy dx, because this one also have the meaning of the gradient of tangent. At point A. So if you maybe want to clarify whether your answer is correct or not, then you can try to differentiate the equation to get the dy dx, and you substitute x equals to 2. By right, you will be having this answer 8 as well, where this is actually the meaning of the gradient of the tangent at this particular point. Right? Yeah, so this is how we solve question number 3. Okay, so we are now at question number 4. They want us to find the term independent of x, which means that I'm looking for the term with x power 0 in the expansion of each of the following. Right, so when we are talking about the binomial expansion, right, the general formula for any term should be NCR. Okay, then so maybe I should write out the original equation first. So I'm having a plus b power n, let's say. And if I want to expand any particular term, the general formula is NCR. You will be having b power r, and then the a is power n minus r. This is a general formula. And usually when you want to figure out the particular term that the question wants, right, we need to do a little bit of thinking or analysis so that we can get. For me personally, I'm using the trial and error method. Okay, because if I try a few sets of power, right, then I roughly know what is the correct answer, or what is the correct power that I should consider. Some students, they will do the calculation if you want, also can. Right. Okay, so let's have a look for this one. They want us to find out the term independent of x. That means there's no power of x in this particular expression. Okay, so let's have a look here. We need to do a little bit of calculation, or maybe a little bit of trial and error here before we can fix the answer. Power 6, right? So definitely it should be 6c something, then x power something, 3 divided by x square power something. Okay, so let us try out the trial and error. By right, you should know that the power for the A and also the power for the B, total must be equals to 6. So the possible combination is, I can have 1 here and 5 here, so that 1 plus 5 equals to 6. But if I have 1 and 5 here, for this term, I'm having x power 1. For this particular term, I will be having 1 over x power 10. Something like k power x over 10. So 1, x power 1, divided by x power 10. Is it possible for me to get x power 0? Impossible, right? So that means this is not the correct combination for the power that I want. So maybe I try the other one. How about if I try out 3 and 3, let's say, because 3 plus 3 also equals to 6, right? Okay, so for this one, if you expand it, I'm having x power 3. For this one, x squared power 3. So I will be having something over x power 6. X power 3 divided by x power 6. Do you get anything with x power 0? No, right? So this is also not the correct power that I want. So this is how we usually carry out the trial error. Okay? It won't take us too long time if let's say you know the process very well. Okay, so now if I want to get something independent of x, I know that the power in front must be slightly larger. The power at the back must be smaller because I'm having a square in the B. Okay, I can try to consider this one, 4 and 2. If I have this, I will be having x power 4. Then this one, x square, you will be having something over x power 4. X power 4 divided by x power 4, you get something with x power 0. So this is the correct power that I want. Once you decide the correct power, then 6CR, the R will be the number at the back, the power at the back, which is the 2. Because NCR with B power R, right? So 62 with the B power 2. Okay, so after you decide the power already, then just try to use calculator and help you to get the answer. So I'm having 15 for 6C2, and then x power 4 is x power 4. Then 3 square is a 9, divided by x power 4. So you multiply all these terms together. And by right, you won't have any term with the x because it is x power 0. So by right, you should be having 135. Okay, so this is how we get the answer for 4A. Let's continue to 4B. Okay, so for 4B, they put another bracket in front of this expansion that we tried to carry out just now. Okay, so let's figure out how to get the term independent of x also for this question. For x3 minus 5 is having power 1, right? So I can't do anything with this particular bracket. I can just copy it. I cannot expand. I cannot do anything for now. For the second bracket here, basically it is what we have in part A. So I know that for x plus 3 over x squared power 6, to get the independent of x term, one of them is 135. So I'll put 135 here. Substitute 135 directly. And then you try to figure out for the answer. If let's say I have 135 here, right? So negative 5 multiplied with 135, I'll get something independent of x. But how about if let's say 4x power 3 multiply with something also in this expansion, I will get something with independent of x as well. So I need to figure out what is this particular term needed in this expansion. Alright, so number multiply with number, I get x power 0. So for x power 3, I need to have something with x power 3 at the bottom, so that for x power 3, multiply with kx power 3, k over x power 3, x power 3 and power 3 can be cancelled off, right? This and this can be cancelled off. Then I also get another term, which is independent of x. And now our aim is to figure out what is the term with 1 over x power 3 from this particular bracket. Okay, alright, so again, I want to get the something with 1 over x power 3 from the power 6 bracket here. Okay, so again, try and error one more time. I'm having 6c something, x power something, 3 over x squared power something. Again, I want to have something with x power 3 at the bottom. That means the power in front must be much more larger than the power at the back. So I can have a try for this one, 5 and 1. X power 5, I got x power 5. So 3 over x squared, I'm having x squared. Alright, then I will be having x power 3 here. Is this the term that I want? I want 1 over x power 3, but this is what I get. I will get x power 3 here. So which means that this is not the correct answer that I want, or correct power that I want. So maybe I have to put the power in front smaller. Okay, if I put it smaller, how about 4 and 2? But just now 4 and 2 you get independent of x, right? Which is not correct. Maybe I should put it as 3 and 3. Okay, so let's have a try. If let's say I put this one as x power 3, I got x power 3 here. This one I'll get k over x power 6. X power 3 divided by x power 6, you get x power 3, something with x power 3, right? So this is what I want in my expansion here. So I know that it should be 6c3. Okay, therefore I will put in the calculation in this part where I need to figure out, I need to calculate out 6c3 x power 3, then 3 over x squared power 3 here, then close bracket. Yeah, so I already decide the correct power here. Okay, so just copy the step first before I multiply them. Okay, so we can use the calculator and try and simplify this particular term. So 63 multiplied with x power 3 multiplied with 3 power 3 divided by x power 6. So you try to simplify this particular term here. By right, you should have 540 over x power 3. Okay, then for this two bracket, if I want to get the term, okay, that is independent of x, I have to take 4x power 3 multiply with this particular term. So if I take 4x power 3 multiply with this particular term, I should be having 2160. Then I cancel off the x power 3 and also the 1 over x power 3, right? Okay, then after that, second term multiply with this particular term to get something which is independent of x. So it is actually 675. So 675 negative. Then if you simplify all the terms here, your final answer is 1485, which fulfill our question because the question wants us to have something which is independent of x, right? So there's no x here in our answer, which means that our answer fulfill what the question wants. Alright, yeah, so this is how we solve question number. Okay, so we are now at question number 5. We are given a function fx, and then it is defined for x smaller than half. Okay, state the value of f negative 1. So I think this is very, very straightforward, where you need to substitute x equals to negative 1 into the function fx. So I'm having 2 negative 1 plus 1 divided by 2 multiplied with negative 1 minus 1. So just try not to make any careless mistake here. By right, your answer should be 1 over 3. This is also a very straightforward question. Then let's have a look for part 2. Okay, for part 2, they give us a diagram here, and let's see what they want. So the diagram shows the graph of y equals to fx. So that means if they try to sketch this particular graph, this is what they get. And then if you have a look for the domain in defined, right? From the graph, you can see that the graph start smaller than half, which fulfill the domain given in the question, x smaller than half. Okay, so this is basically the function fx. Right, then after that, they want us to sketch the graph of f inverse x on this diagram. Show any relevant mirror line. Okay, so now we need to figure out two important things here. The first one is how to sketch f inverse and also the mirror line. So f inverse means the inverse function of f, right? Okay, so by right we have, we should remember, okay? When we are talking about the function f and also the function fx and also f inverse x, basically they reflect each other at the line y equals to x. Okay, so this is basically the mirror line that you should show in the graph. So maybe I should show it first. Y equals to x means that the graph will pass through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. Okay, so you can try to sketch the mirror line here. I will sketch it like this. It should be a straight line, yeah? So you pass through all the 1, 1, 2, 2, 3, 3, 4, 4, and so on. And label it clearly, y equals to x, which is the mirror line. Okay, and now if I want to sketch the f inverse, usually what I do is like, I try to figure out the x and y intersect. Then it will make us more convenient to sketch it, to sketch the f inverse. Right. Okay, so let's have a look for my function fx. My function fx, I'm having 2x plus 1 divided by 2x minus 1. If I let x equals to 0, then I will be having negative 1. So can you see this point? When x is equals to 0, this is negative 1. It's quite obvious, right? Okay, if you let y equals to 0, then your x will be equals to negative half. That means substitute the whole thing here 0, move the 2x minus 1 up, become 0 also, then your x is negative half. Which means that this particular value, you are having negative half and 0. Then this is 0 and negative 1. Okay, so the important step for me, right, because I know that they reflect each other at y equals to x, which means that we are trying to swap the coordinate for x and y in inverse function. Okay, so that means if your original function is having 0, negative 1, because they reflect it at the line y equals to x, you will notice, you'll figure out that the x coordinate will become y in the inverse function and the y coordinate will become x in the inverse function. So 0, negative 1 here will become negative 1, 0. Where is negative 1, 0? So you try to plot it first. I plot it by using the green color. So this is basically the inverse function graph later, right? Okay, then same thing happened for this one, the x coordinate, negative half and 0. So when I swap the equation or swap the coordinate x to y and y to x, it will become 0 and negative half. So where is 0 and negative half? It should be somewhere here. I plot it by using green color as well. Okay, so this is negative 1, 0. This is 0 and negative half. Okay, then after that, you need to connect these 2 points together to, to complete the f inverse. So some students, they might not sure how should I connect these 2 points here. Okay, if you're not so sure how to connect it again, try to have a look for the intersection point. So you can see that the original graph and intersection point of the y equals to x is here. By right, the f inverse and the line y equals to x all should intersect at the same point. So that means you have another reference point here. Alright, okay, then next. Just now we also know that our graph started from the line x equals to half, right? Smaller than x equals to half. And now if you swap it, you know that your line should be drawn, okay, below y equals to half. This is a line y equals to half. That means your graph later should connected to this part. So there are many lines or maybe many points that you can try to refer to and slowly build out your inverse function graph. So I have all these points here. Maybe I can try to connect them now together where it should be something like this. Okay, then I know that my graph, original graph here, getting closer to 1, right? So this part here should be getting closer to 1 as well. So I think my curve is too curved. So I try to control it a little bit. And there this one. Okay, So this green color graph basically is my F inverse. And the black color one is actually the Fx. Alright, yeah, so this is basically how we get the inverse function graph. Okay, alright, then let's continue to part number 2. This is this is part number 2. Let's continue to part number 3. They want us to express an expression for F inverse and state the domain of the function F inverse. Okay, so usually if I want to find the F inverse, I will start from letting the y equals to original function fx. So from here you can see that y equals to something something x, right? Okay, so to find the inverse function, I want to rephrase it become x equals to something something y. Therefore, I bring up the 2x minus 1. Okay, multiply the y inside the bracket. Group all the x at one side. Factorize out the x. Then bring everything over and left only the x on the left hand side. So you can see that now it becomes x equals to something something y. And therefore, this will be my inverse function. Okay, so you'll be looking something like this. Alright, and after that, they are asking also, ask us to find the domain of the inverse function. Alright, so we need to know, yeah, the domain of the inverse function basically is equals to the range of the function. And now, how do I get the range of the function? So please go back to the diagram given here. Okay, so the range means of the function means you have to look at the black color line. So you can see that this is particularly the line y equals to 1, right? Okay, and my graph for the original function, right, is below the 1. So the range for the function basically is y smaller than 1. Okay, so now go back to our question. I know that the range of the function is basically y smaller than 1. Domain of the inverse function should be same as this one, but of course I cannot write out as y because domain we have to represent it by using the x. So basically it should be x smaller than 1. This is the domain for the inverse function. Yeah, then let's continue to next part, part number B. Now they give us another function g, which is this gx equals to 3x plus 2 for any value of the x. They want us to solve this particular equation here, fx equals to gf 1 over 4. Okay, so let us try to solve it now. Fx is the function 2x plus 1 divided by 2x minus 1. We are talking about gf 1 over 4, so g, I have to substitute 1 over 4 into my function fx. So I'm having 2, 1 over 4 plus 1 divided by 2. The x is 1 over 4 minus 1. Okay, so we have to simplify the value inside this bracket. I'm having a negative 3 here. So 2x plus 1, still the same, right? 2x minus 1. And now I have to substitute negative 3 into my function g. So when I substitute negative 3 into my function g, it will look something like this. 3 times negative 3 plus 2. Okay, so 3 times negative 3 plus 2, you should have a negative 7. So I try to solve the equation now, yeah. So I'm having negative 7, bring up the 2x minus 1. Simplify everything, try to get the value of x. Okay, so by right, yeah, you should be having 16x equals to 6. And your x is equals to 3 over 8. Okay, yeah, so this is basically how we solve the question number. Okay, so question number 6. Right, so the diagram show a metal plate. So this is the metal plate. Then consisting sectors of two circles. So there are two sector from two circles with the center O. The radius of the sectors AOB and also EOF are RCM. So I think they are talking about this. So these are two sectors from the same center, okay, and the radius is R. Then after that, we are having another sector, which is a bigger one, COD. Right, so for the COD, the radius is 2R. Then they also tell us that the angle AOB and EOF are the same, which is theta. So they have label it here. Then angle COD is 2 theta. Alright, so basically the paragraph is talking about what do we have lah, okay, in the diagram. Okay, so now let's have a look for part A. It is given that the perimeter of the plate is 14. So they are talking about perimeter 14. Then they are talking about the area of the plate is 10. So by using these two information, they want us to get the value for R and theta. But of course, they did tell us some condition or maybe the restriction for R and theta. So R must be greater than 3 over 2 and the theta must be smaller than 3 over 4. Okay, right. So before we can start, just do a very quick recall when they are talking about the perimeter of the plate, right? So you can see that if talking about perimeter, all the length here are straight line. Okay, we want to calculate and add all the length that form the metal plate. Okay, so all the straight line is we have no problem to find out lah. So mainly we're having these two curve here. Basically for these two curve, all these curve here, there are three curve. Okay, so for the three curves here, basically they are the arc of the sector. Okay, so how to calculate the arc length? So in general formula, the arc length should be r theta, where you take the radius multiply with the angle. Okay, then this is for arc length, and after that they are talking about the area as well. So what is the formula for the area of a sector? So it basically it is half r square theta. So this is these are the two important information or two important formula that we are going to use it to solve the question. All right, so we'll start with the perimeter is 14 cm first. I think I will solve it directly here so that you can refer to the diagram easier. Okay, all right, so first we will start with perimeter. Perimeter equals to 14. And now we need to add all the length together, right? Okay, so maybe you can start from all the length first. So maybe you start from AO first. So the length AO basically is the R. Same thing happen for the length OF, also is the R. Okay, then how about the C and B? From C to O is 2R. From B to O it is R. Therefore from C to B it is 2R minus R, which is a R also. And then from D to E is also the R, right? 2R minus R, you get R. Then now we try to consider the arc length. Okay, so for this arc length CD, the radius is 2R and the angle is 2 theta. So arc length will be R theta, so 2R multiplied with 2 theta. Okay, then what else do I have? I still have the arc length AB. Arc length AB and also the EF should be the same. Alright, so you can directly take 2 multiply with R theta. So the radius is R, the angle is theta. And this whole thing equals to 14. Because it is given that the perimeter equals to 14. So when you add all the sides that build out the metal plate, right? So this is the formula that we have. Okay, so we try to simplify everything here. So we are having 4R plus 4R theta plus 2R theta equals to 14. Then if I try to further simplify it, 4R plus 6R theta equals to 14. Okay, then I further simplify my answer where 2R plus 3R theta equals to 7. Okay, so if you want, you can express R in terms of theta or theta in terms of R so that later you can solve the equation simultaneously. Alright, but for me, I'll just keep it like that first. Then later only I see how I want to express my equation. Okay, then now we go to the second information given. Yeah, the second information given basically is this one. The area of the plate is 10. So now I know that the area is 10. To get the area for the sector, so you're having the area AOB and also the area EOF, which is the same. And the general formula will be half r square theta, right? So I'm having 2 times of half r square theta. 2 times because of these two sectors are the same. So for one sector, it is half r square theta. Then plus, how about the area for the large sector here? So the area for the large sector will be half r square. So r square here is 2r square. Okay, because the radius is 2r. And then theta. So the theta here will be 2 theta. Because the angle is 2 theta. Alright, and this whole equation, it is equals to 10 because the total area equals to 10. Alright, so I try to simplify my answer here. I'm having r square theta plus 1 over 2, then 4r square, and also 2 theta equals to 10. And after that, I will be having r square theta. Simplify the term here, you'll be having 4r square theta equals to 10. 5r square theta equals to 10. And I want to express my 5r square theta as 5r, then r theta equals to 10. Why I want to express it in this way? Because I want to go back to my first equation just now. I want to rephrase my r theta equals to 7 minus 2r divided by 3. Okay, and now I want to substitute this particular equation into the r theta here. So substitute it, I'm having 5r, then 7 minus 2r divided by 3 equals to 10. Okay, and now you can see that I have already get rid of the theta, right? Okay, so this one you sub 1, the equation number 1 here. So you can continue from this part, try to simplify the equation. So by right, I will be having this 5 and 10 can be simplified. So this one become 2. Okay, so I bring the 3 over. If I bring the 3 over, then I will be having 7r minus 2r square equals to 6. Okay, so rephrase my equation again. I'll be getting 2r square minus 7r, then plus 6 equals to 0. Then you will realize that you're able to factorize this particular equation here. I want to have negative 7, so it should be negative 2 and also negative 3. So r equals to 3 over 2 and also r equals to 2. I have two answers for the r, right? But according to the question again, just now they did mention that our r must be more than 3 over 2. Therefore, r equals to 3 over 2 should be ignored, right? Should be neglected. So I'm using the value for r equals to 2. So how can I get the value for theta? So now, when r equals to 2, I can substitute it into my first equation. What do I have here is r theta is 7 minus 2r over 3. Okay, 7 minus 2r over 3 equals to r theta. So I will have something like this. R theta means 2 theta equals to 7 minus 2r over 3. So 7 minus 2r, r is a 2 over 3. So from here, if you try to simplify your answer, right, by right, you should have 1 over 2 for your value of the theta. Okay, so basically for this question, we are trying to solve the equation simultaneously to get the value for r and also the theta. Alright, so the formula involved will be the arc length, alright, and how to calculate the perimeter. At the same time, also the formula of area of a sector. Okay, so this is how we solve question number 6. So now we are at question number 7. So part A, they want us to express this particular quadratic expression into this form, which is a completing square form. And then A, B, and C are positive integers. Then after that, they want us to find the coordinate of the vertex of the graph with this equation. Okay, so completing square, right? So when you want to completing square, you have to make sure that your coefficient of x squared is a 1. So I have to factorize out -2 first. Then I will be having x squared, then minus 4x. Okay, then after that, I have to carry out the process of completing square, which is plus something square and minus something square. Then I want to close the bracket. And then originally we have a plus 11, right? It is not involved in my completing square, so I'll just leave it outside. Alright, so I factorize out the -2 for only the x squared and also the x, the term in the x. Okay, then after that, what we are going to do is, what should I fill in for this plus something square and minus something square? So the something here should be -4, the bx, right? So the -4 divided by 2, so you're having a -2 here. So -2 and -2. After that, you need to combine the first three terms into one big bracket with a square outside, which means that you'll be having x minus 2, and then with a square outside, then minus -2 square, you get a 4, then plus 11. Okay, so next step is you have to expand back or multiply back the -2 into the every single term in the bracket, right? So you'll be having -2 and then x minus 2 square plus 8 plus 11. So gather together the plus 8 and also plus 11. So you're having positive 19. So this is what they want us to show, alright. Express our quadratic expression into this pattern. So you can double check your final answer. The -a means -2. A is a 2. -b means -2 also, which is a 2 as well for the b. And then the c is positive c, which is a positive 19. And correct, you can see that the pattern follow what they want, and also all the value for a, b, c are positive integer, which is correct, right? Then now they want you to find the coordinate of the vertex. So like what we know earlier, when you express your quadratic expression into a completed square form, basically it already showed the coordinate for the vertex, right? So just in case you already forget, the x coordinate, right, you are taking out from the bracket here, so you're having x minus 2 equals to 0, then your x is equals to 2. Then for the value of y, this is directly the value of y. Therefore, the coordinate of the vertex will be 2 and also 19. So this is basically the coordinate of vertex. Alright, so let's have a look for part B. Okay, so for part B, we are given a diagram. And now they want us to, the diagram show part of the curve with the equation y equals -2x squared plus 8x plus 11, which is the equation that we have on top, right? And after that, and the line with this equation, y equals to 8x plus 9, find the area of the shaded region. Alright, so to find the area of the shaded region, basically it involves integration. Okay, it involves the integration, but you can see that for this particular area, right, it is actually bounded by the curve and also the line. So when the area is bounded by the curve and also the line, as an example, so this one, the curve is on top. So when you want to find the area, right, you have to use the curve equation, where I label it as y1, curve equation. So if you integrate the curve equation, right, you'll get the whole area below the curve. Then I have to minus the area from the straight line. Okay, so from the straight line means this one, this straight line, I will label it as y2. Okay, so basically you have to use y1 minus y2. Then when you integrate, only you can get the area under the graph. But the problem is I need to know where's the limit of starting. Okay, where's the limit of my integration? So you can see that the area starts at this point and the area ends at this particular point from the diagram. So I need to know what's the value for x1 and x2. To get the value for x1 and x2, observe from the diagram, you know that they are actually the intersection point for the curve and also the line. Alright, Therefore, if you want to find the area, the very first step is you need to find the intersection point for this line and also the curve first. After that, only you can apply it as the limit in the integration to get the area. Okay, so generally this is what we need to do for this particular question here. Alright, so first of all, I want to find the intersection point. So how can I find the intersection point? You have to solve the equation simultaneously. So you solve this curve equation and also the line equation simultaneously, yeah? Curve and line equation simultaneously to get the x coordinate. So I'm having negative 2x squared plus 8x plus 11 equals to 8x plus 9. Okay, so I try to simplify my answer here. I'll be having 2x squared equals to 2. Then x squared equals to 1. And therefore my x is equals to plus minus 1. So from here, you know that your x1 is equals to negative 1 and your x2 is 1. Okay? So after you find out the x coordinate for the intersection point, then you can start with the area. So maybe for the integration, I put it here, yeah. Okay, so how to get the area? So like what I told you just now, you know that you have to integrate, right? Okay, so excuse me, I will want to leave more space. Okay, so to get the area, basically you need to integrate from -1 to +1, and you take the curve y1 because the curve is on top, like what I showed you just now. So the curve is negative 2x squared plus 8x plus 11 minus the line equation. So the line equation is what? Is 8x plus 9. Okay, then try to integrate and get the area. But usually before the integration, right, my personal habit is I prefer to simplify my expression first before I integrate them. I feel that maybe this one can make the step or solution slightly shorter, and then it's easier to avoid. Is helping us to avoid making careless mistake. Right, so I'm having negative 2x squared. Then 11 plus 9 I get a plus 2. Sorry, 11 minus 9 I get a plus 2. Then from here you can see that my equation become very simple and you can start the integration. So integrate negative 2x squared. I'll be having negative 2 is a constant, I just copy. X power plus 1 become a 3 divided by the new power. And then integrate the 2, you have a 2x. Then you need to substitute in the value of 1 and also negative 1. Alright, so substitute 1 into the equation, you'll be having negative 2 over 3 plus 2. Then substitute negative 1 into the equation, you'll be having 2 over 3 minus 2. Then just simplify this particular number. Then by right, you should be able to get 8 over 3. Okay, yeah, so this is how we solve question numbers. We are now at question number 8. We are given an equation of circle in general form, and then they want us to put it into this standard form, where A is to be given in terms of P and also R squared is to be given in terms of P and Q. Alright, so for your information, from general form to standard form, basically you have to carry out completing square. Okay, and you have to complete square for both x and y. Alright, so let us start. I will copy the equation for x first. I will copy and group all the x together first. Then plus y squared plus 2y plus q equals to 0. So first step, I will want to complete square for the x. So I need to have plus something square and minus something square. So what's the something for the x? So again, like what I told you just now, earlier in the previous question, it is actually p divided by 2. So p divided by 2. So this is also p divided by 2. Okay, this is for the x. And then for the y square, you also need to have plus something square minus something square. So what's the something here? So you take 2 divided by 2, you get a 1. Okay, then after that plus q is a constant term, so you don't do anything for now, then you let it equals to 0. Okay, then for the x here, I want to group the first three terms together, become one big bracket with a square outside. Same thing happen for the y here. Okay, so for x, if I try to compile it, it should be x plus p over 2 square minus p square over 4. Okay, then for the y, I will be having y plus 1 square minus 1, then plus q equals to 0. Okay, yeah, so we are very close to the standard form already. And if you have a look for the standard form given in the question, right, they are asking for x minus a squared. Therefore, what I need to do is I have to express my answer into x minus, the a is negative p over 2. So x minus a and then square. For the y also the same, they want to have y minus b squared. Therefore, for the y plus 1, I have to make it become y minus negative 1 and then square. Equals to, they want to have r squared. If I try to move all the number to one side, right, I'm having p squared over 4 plus 1 minus q. But they want us to have r squared. This whole thing is r squared. You can keep it in this form, or if you want, you can further simplify it like this. Okay, so to make sure that I am having a square here, right, I have to make this r squared become square root r, and then you square it. Okay, so this is basically what they want us to express. Okay, from a general form of a circle into the standard form of a circle. So you can double check and see, is it A in terms of P? So your A is in terms of P, correct? And then is it R squared in terms of P and Q? So in the R squared here, you are having both P and Q, which is also correct. Right? Yeah, so this is how we complete the square to get a standard form of a circle. Then let's continue to part B. Okay, so for part B, they are saying that the line is the tangent to the center at the point. Okay, so they want us to find the equation of the normal. So how are we going to figure out the equation of the normal? So first of all, when we are having the equation of tangent, right, we put it into a general form of y equals to mx plus c. So if I have y equals to mx plus c, you can observe that your m is basically the negative half. Okay, and this gradient is the gradient of tangent. Because they said this is the line, it is a tangent to the circle, right? So the half, negative half will be the gradient of tangent. Alright, so we learned previously one formula where if you take the gradient of normal, multiply with the gradient of tangent, it will be equals to negative 1 because they are perpendicular to each other. So from here, very easily, I will get the gradient of the normal. So the gradient of the normal will be negative 1 divided by negative half, and by right you have a 2. Okay, and how can we form the equation of the normal? When we want to form any linear equation, I need two information. The first one is gradient, and the second one is the passing point. Okay, so the gradient of normal I have already, which is a 2. Passing point also have, because they are saying that the normal at the point A. So basically the point A will be my passing point of the line, and you can form the equation from here using these two information. So equation of normal will be equals to y minus y1, which is the y coordinate of A, equals to m. M is gradient, then x minus x1, which is a 4. Then from here, you can try to simplify it. Okay, so if you didn't do any careless mistake, by right, your equation of normal should be y equals to 2x minus 5. Right, so this is part B number 1. Then let's continue part B number 2. at the next page. Okay, so for part B number 2, now they want you to find the values of P and also the Q. Okay, so now let's go back to this question just now. Right, so for this question, right, they did mention that the equation given is a tangent to the center, to the circle at the point A, right? Okay, so what is the gradient of the normal? So you know that the gradient of the normal, we already calculate this is a 2. So the gradient of normal also have the meaning where it is the gradient from the center to the point A. Agree? Okay, so you can see that the gradient of normal is a 2, but at the same time, the gradient of normal also means that it is a gradient from center to point A. Okay, alright, so let's go back to the question here. To find the values of P, I try to link the gradient of normal is basically equals to the gradient of center and point A. Alright, so what's the center for this particular circle? So we go back to part A again. So from part A, you know that the center coordinate is negative P over 2 for the X, negative 1 for the Y. Right? Okay, so negative 2 and also, negative P over 2 and also the negative 1. So I write out here first, yeah. Negative P over 2 and also negative 1. Then what about the coordinate for the A? Coordinate for A is 3, 4, right? If I'm not mistaken. 4, 3, sorry, 4, 3, okay? Right, so it is 4, 3. Okay, so the gradient of normal is equals to the gradient of center to the A. So gradient of normal equals to 2. How to get the gradient of center to the A? So you have to take y minus y1, y1 minus y2, sorry, divided by x1 minus x2. So you're having p over 2 minus 4. Okay, so this is y1 minus y2 divided by x1 minus x2. Okay, so I try to solve this equation. By right, you see that it is not hard for you to get the value for p, right? Okay, so simplify the equation here. You'll be having negative p minus 8 equals to negative 4. So your p basically is equals to negative 4. Okay, so this is how you get the value of the p. Then how can I find the value of q? Okay, so we go back to the question one more time. If you have a look for the q, basically q involved in the radius of the circle. Alright, so q is involved in the radius of the circle. Radius. How to get the radius for the center here? So the radius of the center basically is the distance from C to A. Again, right? Okay. So now to find the Q, I will use this formula lah, or this information. Distance from center to A is equals to radius. Okay, so how to get the distance from C to A? So it will be x1 minus x2 square. So what I do is like, I will take x, negative p, but p I know that it is negative 4, right? Therefore, now, if you have a negative p here, then you're having negative 4 divided by 2, and you get a 2. So your center now become 2 and negative 1. Okay? And now, please use this new value for the center and substitute into the distance formula. So you're having x1 minus x2 square plus y1 minus y2 square, and it is equals to the radius. So what is the radius of the circle just now? So the radius is this one, square root p square over 4. So your p is a negative 4, right? Okay, so square root p square over 4 plus 1 minus q. Okay. So your radius is equals to square root of b square over 4 plus 1 then minus q. So if your p is 4, so 4 square becomes 16. 16 divided by 4, you get a 4. 4 plus 1, you get a 5. So your radius can be expressed as 5 minus q. Okay? Yeah. So I will substitute it as square root 5 minus q. Okay, so try to simplify the answer on the left hand side and get rid of the square root. You can cancel off the square root on both sides. So you're having 2 square plus 4 square. So 2 square is a 4, 4 square is a 16, and it is equals to 5 minus q. So from here, very easily, you can get the value of q, which is negative 15. Right? Yeah, so this is how we solve the question number. So we are now at question number 9. Given the equation of a curve, right, so this is the equation of the curve that we have. And also there's a linear equation, y equals to kx plus p, where the k and p are the constant with the k from 0 until 1. Right, so it is given that one of the point of intersection of the curve and the line has the coordinate 5 over 2 and 1 over 2. So you are given a value of x and y that is on the curve. Okay, so find the values of k and p, and also find the coordinates of the other point of intersection. Alright, so first of all, you need to find the value for k and p first. So if we have a look for the first equation here, we are having x, y, and k. And since we are given the coordinate of x and y on the line, right, on the curve, therefore you can substitute this particular point into the curve equation and you can get a k easily. So let us start. I'm having y equals to kx squared, half k squared x squared minus 2kx plus 2. Substitute the coordinate where y equals to half. The x is equals to 5 over 2 minus 2k, then 5 over 2 plus 2. Okay, then we try to simplify this particular equation here. I'm having 25 over 8k squared, then minus 5k plus 2. Alright, so if I try to simplify all the terms, I multiply the whole equation by using the 8 because I want to get rid of the 8 in the denominator. So I multiply the whole equation by using 8. So 8 divided by 2, you get a 4. Then simplify this one, you have 25k squared. Then you're having 40k here. 8 times 2 is 16. Eventually, when you try to simplify it, you will be having this quadratic equation in terms of k. Okay, and now to get the value for k, basically we can factorize out the equation, the quadratic equation here. I will be having 5k until 2, then 5 and 5, right? Then 6. Okay, so we're having k equals to 2 over 5. And also k equals to 6 over 5. Okay, but we'll ignore this particular answer. We'll ignore the k equals to 6 over 5. Why? It is because of, they did mention in the question that the k value must be between 0 until 1. Right, therefore 6 over 5 is more than 1. Therefore, ignore this particular answer for the k, and we just accept one answer for the k, which is equals to 2 over 5. Okay, so we are done with this part to find the k. And after that, they want us to find the p. To find the p, we might need to use this linear equation, because this linear equation, right, and also the curve, they intersect each other. So this is one of the intersection point. Therefore, this point, we can substitute into the curve. We can also substitute into the linear line, which is the true equation, right? Because this is the intersection point for this curve and this line, right? Okay, so if you substitute the coordinate inside the linear equation, it can fulfill the equation also. Alright, so I will substitute inside. Okay, I'm having linear equation y equals to kx plus p. substitute the y, which is the half, substitute the k that we get just now, which is a 2 over 5, substitute the x, which is 5 over 2, and then plus p. So from here again, very easily you get a value for p, which is negative half. Alright, then after we get the value for k and p, they want us to find the coordinate of the intersection point. So this is one of them. By right, you should have another intersection point. So they want us to find that particular intersection point. So usually when you find an intersection point, we will need to solve the equation simultaneously, where we solve the curve equation and also the line equation at the same time. You can either substitute the line equation into the curve, or you can just solve them simultaneously and try to get the x and y coordinate. So let us start by replacing all the value that we get here for the k and p. Okay, so what do I have here when I want to solve for quadratic, when I want to solve for the intersection point? So I will equate equation number 1 equals to equation number 2 lah. So for the curve equation, I'm having half k square, so k is 2 over 5 square, then x square, what's the value, I don't know yet, then minus 2kx, so 2kx, alright, then plus 2, so plus 2, and it is equals to the linear equation. So what's the linear equation here? Kx plus p, so k is 2 over 5 x, then p is negative half. Okay, so I will group all the x squared together, or I will group all the constant term and everything to the left hand side, and I try to simplify that we can. Okay, so by right I'm having 2 over 25x squared for this particular term, then 4 over 5x. Okay, so 2 plus half, so 2 plus half, I'm having 5 over 2, and then the 2 over 5x bring over become negative 2 over 5. Okay, so further simplify for the x. Okay, so I will be having 2 over 25 x squared minus 4 over 5 minus 2 over 5, and therefore you're having negative 6 over 5. Okay, then again, before I can factorize it, I will want to multiply the whole equation by using 25. Okay, so multiply with 25 to get rid of the denominator. So when I multiply every single term with the denominator, I'll be having so let's have a look. Sorry, I cannot multiply 25 here, because if I multiply 25, I can only get rid of 25 and 5. The denominator 2 is still there. So what I need to do is I have to multiply with 50 so that everything can be simplified for the denominator, right? Okay, so if I multiply the whole equation with 50, I'll be having 4x squared, then minus 60x, then 25 times 5, you're having 125. Then from here, we can attempt and see whether can we factorize or not. So there's a hint for us to factorize already, because previously they did tell us that your x is 5 over 2. So when your x is equals to 5 over 2, if you bring the 2 over, you'll be having 2x minus equals to 5. And after that, you're having 2x minus 5 equals to 0, where this is basically one of the bracket of factorization. Alright, so you can directly put this value inside our factorization here. So you should be having 2x minus 5. Then this one should be a 2x. The number at the back here, multiply with 5 to get 125. So it should be negative 25. Okay, so from here, you'll get x equals to 5 over 2, which is already the coordinate of the intersection point that you have. Okay, so we are going to ignore this one. And the other intersection point will be x equals to 25 over 2. Okay, so ignore this one because it has been given. It is actually the intersection point given in the question already. So I don't want this one anymore. Okay, so I will just focus on x equals to 25 over 2. And then to get the value of y, what we need to do is substitute into the linear equation. For me, I think substitute into linear equation is easier instead of you substitute into the curve, right? Okay, so y equals to kx. So k, the new x that you get is 25 over 2 minus the p, plus p. So p is negative half. And from here, you'll get your value of y equals to 9 over 2. Okay, so if you want, you can try to write out your answer clearly where the intersection point, right? What is the coordinate for the intersection point? It will be equals to 25 over 2 and also 9 over 2. Alright, so this is how we get the intersection point for this question. So we have part B, right? Okay, so this is part A. So let's continue to part B. Okay, so question number 9b. It is given instead that the line and the curve do not intersect. So highlight the keyword do not intersect. When you're having a line and also a curve, right? This is a curve, let's say, and this is a line. When they do not intersect with each other, basically it is like the case where the curve doesn't have x-intercept or doesn't intersect with x-axis. Alright, so during that case, basically if we are having a quadratic form equation, then we can use b squared minus 4ac smaller than 0 because there's no root. Seems like it is no root, no intersection point means no root. So I have to use a discriminant concept where b squared minus 4ac should be smaller than 0 when the curve and the line doesn't intersect with each other. Alright, so we have to put in our curve equation and also the line equation, the linear line equation, and see what will happen. Okay, so I let the curve equation equals to the linear equation, which is kx plus p. Okay, so you have to take note that I cannot substitute any value of k and p that I get from the previous part, because in the previous part we already assumed that the curve and the line are intersect with each other. Therefore, you have the intersection point. But for this case, for this question, there's no intersection point. They did say that do not intersect. Therefore, I cannot use the intersection point in the first part to get a value for k and also p and substitute it here. Right, so you need to keep both unknown k and p in solving this question. Okay, so again, I want to rephrase all my terms to one side. And from here, I can see very clearly that my equation is still a quadratic form equation. Okay, so when I'm having this quadratic equation and if I want to solve for this question, they say do not intersect. So I have to use the concept of b squared minus 4ac smaller than 0. So now I will substitute in all the relevant terms. What is the b in this case? So b means the coefficient of x, which is negative 3k. So negative 3k squared minus 4. What is the coefficient for the a? What is the coefficient for the x squared? A is the coefficient of x squared, which is half k squared. So you can put in half k squared here. Then what is the c? C is this constant term, which is 2 minus p. And it is smaller than 0. Okay, then we try to simplify everything. Alright, so 9k squared minus, you are having now 2k squared. Okay, multiply with 2 minus p smaller than 0. So you're having 2k squared, 2 minus p greater than 9k squared. 2 minus p greater than, you divide the 9k squared with 2k squared. So you're having 9 over 2. And after that, to get the p, it is equals to 2 minus 9 over 2, where you can get the final answer, p is smaller than negative 5 over 2. Okay, so what is the meaning for this particular p here? Okay, if the p, as long as the p is smaller than negative 5 over 2, right, then basically the line and also the curve will not intersect with each other. Right, so this is how we solve question number 9. Okay, so we are now at question number 10, which is the last question for this paper. We are having a function f with the domain x greater than 0. And then we are having this f prime x equals to this equation. It is given that the curve with the equation fx pass through the point 1, 0. This is one of the passing point for the curve. And then find the equation of the normal to the curve at the point 1, 0. Okay, so they're asking us to find the normal to the curve. Alright, so as what we know, right, normal, before we can get anything about normal equation, I need to link it with tangent first. So first of all, we should know that tangent is equals to the dy dx of f prime x if you put a certain value for the point on the curve, right? Then we can find the gradient of tangent first. Then after that, we can find the gradient of normal and form the equation. Alright, so let's start. For our f prime x, I want to substitute the value x equals to 1 into the differentiation f. Alright, why? It is because I want to get a gradient of tangent. Alright, so I'm having 8, and then 2 multiply with 1 minus 3 power 1 over 3, and then minus 10. You're having 1 power 2 over 3. Okay, so by right you should be having negative 18. And this is actually the gradient of tangent. Okay, all right, then maybe some of you will ask, why I need to substitute x equals to 1. So the reason is because of we know that they want us to find the normal equation at the point 1, 0. So at this part, at this point 1, 0, I want to get the normal equation. Therefore, I have to substitute x into the f prime x to get the gradient of tangent first. So this is the gradient of tangent we get. So how about the gradient of normal? So the gradient of normal multiply with gradient of tangent should be equals to negative 1, right? Because they are perpendicular to each other. So this result gives us that the gradient of normal should be equals to 1 over 18. Okay, so now you have the gradient of normal. You also have the passing point, okay, of the normal equation. So we can form the equation of normal. Okay, so what is it? Y minus y1, which is a 0, equals to m. M is the gradient, 1 over 18, then x minus x1. And if you try to simplify it, by right, you will be having 1 over 18x minus 1 over 18. Alright, so this is how we get the normal equation for the curve at this particular point. Okay, then now let's continue to part number 2, part B. They want us to find the function fx. From f prime x to fx, basically we need integration. Alright, so we start the integration now. Fx equals to the integration of the function f prime x. So this whole thing is the function f prime x, right? Okay, so we'll be integrating the expression here. A is a constant, so you just copy. Then copy the bracket, power plus 1 become 4 over 3 divided by the new power. Differentiate the thing inside the bracket, you get a 2, right? So you have to divide it by a 2 also. Then minus 10 is a constant, we just copy it. Power 2 over 3 plus 1 become 5 over 3. And I divide by the new power, which is 5 over 3. Then, of course, don't forget about the constant term at the back. So we are having a plus c here. Okay, so I need to know what's the value for parts, the c. So I have to substitute the passing point of the curve, which is 1, 0. Okay, so what will happen for fx? So the fx means y, which is equal to 0. If I simplify the very first term here, right? By right, I will be having 3 and then 2x minus 3 power 4 over 3. So 2x, x means 1, minus 3 and then power 4 over 3. Minus, then 3 times 2 is a 6. X power 5 over 3. That means that I'm having 1 power 5 over 3 and then plus c. Okay, so from here, we try to simplify the c very carefully. By right, if you don't do any careless mistake, your c is equals to 3. And now I prefer to write out the equation again, where you should be having 3 and then 2x minus 3 power 4 over 3. Then minus 6x power 5 over 3 and plus c. C is the value of 3. Right, so basically, this is how we get the function fx. Okay, then proceed to part C. Okay, so for part C, what do we have here? Okay, so it is given that the equation f prime x equals to 0 can be expressed in this particular form. Determine making your reason clear is the function f increasing, decreasing, or neither. Okay, so usually when they are asking for increasing, decreasing function, right, I will always focus on f prime x. If let's say my f prime x is always smaller than 0, then the function is decreasing. If my f prime x is positive, greater than 0, that means it is an increasing function. If the f prime x sometimes increasing, sometimes positive, or sometimes negative, then it should belong to the neither, right? Okay, so let's start with f prime x equals to 0 first. How can I get this particular equation? Yeah, all right, because my f prime x originally is this one, 8, and then 2 minus x power 1 over 3 minus 10, then x power 2 over 3 equals to 0. Okay, so for this particular expression, right, it's very hard for me to determine whether is it a positive value or negative value or it's a mixture of them. So I try to get rid of the cube root first because we're having the cube root here, which is a bit troublesome for us. So what I want to do is like I simplify my 8 and 10 first. Okay, to get rid of the cube root, you need to take this whole equation power 3, everything power 3. So 4 power 3 you get 64. The bracket power 3 you have 1 over 3 times 3 lah, which is a 1. 5 power 3 you get 125. X power 2 over 3 power 3. Power 3 means times 3. Then you're having x squared. Okay, and if you try to simplify, expand and everything, so you're having 128x, then minus 192 minus 125x squared equals to 0. Then if I try to rephrase it again, I'm having negative 125x squared plus 128x minus 192 equals to 0. So if I multiply the negative to the whole equation, basically this is how I get this one. Alright, but this is not important. What I want to do now is to determine whether is it an increasing, decreasing function, I need to complete square for this f prime x. Okay, so the f prime x, after I get rid of the cube root, right, the patterns look something like this. So I will start from here. Alright, so maybe I can continue at the down part here. Okay, so I'm having f prime x is equals to negative 125x squared plus 128x minus 192. Okay, so maybe some of the students will ask, why am I using f prime x equals to negative 125x squared? Why I cannot use 125x squared negative 128x plus 192 for completed square, to complete the square? Okay, so I'm taking negative 125x squared, but not taking this one. The reason is because of, if you have a look for the original f prime x, this is the original f prime x, right? The power with 2, I mean the square, okay, is having a negative coefficient. Alright, so to make the operation, right, to get rid of the cube root easier, what we do is that I bring the negative 10 over, become positive 5. Then only I take the cube root and replace everything. So when I want to put it back into the f prime x, what I'm going to do is I will need to make sure that my x squared is still having the negative coefficient. Can you see that? So this is something with power 2, okay, with a negative coefficient. So after you get rid of the cube root, I also want to keep it as negative coefficient for x squared here. So that's the reason why when I want to complete the square, I'm using the negative 125x squared, but not this one as shown in the question. Okay, all right. So let's take out the negative 125, because before complete the square, you need to make sure that the coefficient x squared is a 1, right? So I'm having x squared, then plus 64. Oh, sorry, it should be a minus here. So minus 128 divided by 125, because you take out 125. Okay, then plus something square minus something square, if I want to carry out the completing square process. So plus something square minus something square. Negative 192, right, does not affect in our calculation, so I just keep it outside. Okay, so it's a something square plus something square and minus something square that I should fill in here. It will be b, which is your b, this one, negative 128 divided by 125. So I have to divide it by 2. So you're having negative 64 over 125. So plus negative 64 over 125 and also negative 64 over 125. Okay, then now I want to compile the first three terms into one big bracket with a square outside. So I'm having negative 64 over 125 with a square outside. Okay, then if I try to expand 64 square divided by 1 and 125 square, so we will have 4096 divided by 15625 minus 192. And now for this particular step here, I need to multiply 125 negative into both terms in my big bracket. Therefore, I'm having negative 125 x minus 64 over 125 square. Then plus, multiply these two numbers, you're having 4096 divided by 125. Okay, then minus 92. Because I already expand everything, right? Then rephrase this again. Okay, so you have negative 19904 divided by 125. So after I settle the complete square form, you can try to observe that when you are having a negative 125 multiplied with anything positive, it is always negative. Then you minus a negative number, it actually makes the whole expression here become negative value, right? So you can tell them that this whole phrase here basically is always negative. And since we know that this is actually our f prime x, right? So you can conclude it in this way, where f prime x is smaller than 0, always negative, so always smaller than 0. Therefore, the function fr is a decreasing function. Okay, so for this question, right, personally, I feel that it is a bit tricky. Okay, so the tricky part is actually on this one. They tell you that, oh, the f prime x can be expressed like this. So a lot of students, they might not aware, right? They directly complete the square from positive 125 x squared. But actually, to make sure that it is correct, you have to follow the original f prime x sign. So for the original f prime x sign, you're having negative 10 for the term with x squared. So when I already get rid of the cube root, I also need to make sure that I keep the coefficient of x squared, which is a negative value still. Then from there, only I start the completing square process. Alright, and for your information, this part of the solution, no need to show in exam. I just want to show you how I actually get the equation here from the original f prime x. So this one no need to show. No need to show in exam. But just make sure that you, when you want to complete the square, right, please make sure that you are having negative 125 x squared, not the positive one. If not, you'll totally get the opposite answer. Alright? Yeah, so this maybe this question you have to take note a bit. To me, I think it is quite tricky because a lot of students, they won't think so much. Right? Okay, so this is what we have for our October, November 2024 paper 1-2. Alright, so thank you very much for watching the video.